function. The average rate of change over any length input value interval is constant. That makes sense to you, right? Because if you're linear, your average rate of change is your slope, so it isn't gonna matter, that's gonna stay constant. We often think of this as the slope of the line. All right, let's look at example 1. Can you explain why this chart does not represent a linear function? Can you think of a good mathematically sound way that you could say definitively this is not linear? What do you think, Albert?
Because the rates of change rates of changes are different.
So this is 3 and 3 and 3, right? You have the y's. And my x's are 1 and 2 and 4. So for these 2 points right here, the average rate of change, I'll call it the slope, actually I should call it average rate of change, would be 7 minus 4 over 2 minus 1, which is 3 over 1, so it's 3. But what about here? So that's the first 2. What about these 2? What's your average rate of change here? Well, it would still be 3, but now it's over 2. And here, your average rate of change is 3 over 4. If you are linear, that ratio will be the same. These numbers can be different, but these would then also have to be different so that you had a ratio be the same. Is that all right with everybody? All right. Consider the quadratic function x squared. Complete the table of values over the consecutive equal length input intervals below. Okay. So when he keeps talking about these consecutive length input values, look at your input values. These are your inputs. Look at them. What do you notice about these? They're all 2. That's what he means by equal length input values. All right, go ahead and fill in this side. Then complete the table for the average rates of change. Find your average rate of change. Did you fill in your y values here? Now, I had already figured out that my change in x was 2 each time, equal length input intervals. So I went ahead and figured out my changes in y. So this was like y minus y. So I had my change in y and my change in x. So it was easy to fill in my average rates of change. Does anybody have a question about any of these numbers over here? You got them? So the average rates of change are 4, 0, 4, negative 4, 0, 4, and 8. What do you notice about those average rates of change?
They're all like 4 apart, right?
Uh-huh. So in other words, these numbers, the average rates of change, are linear. The average rates of change are going up by the same amount, 4 apart. That means they're linear. That is a characteristic of a quadratic function. So in a linear function, these would all be the same number. In a quadratic function, you're going to be going up or down by the same amount. Okay, so one more time. Because at some point, someone's going to give you a table of values, and they're going to say, is it linear, quadratic, cubic, logarithmic, exponential? And you're going to have to know the characteristics. So, linear means the average rates of change are the same. So if you did all of your average rates of change, and you got 4, 4, 4, 4, got it, linear. When you get average rates of change that are all changing by the same amount, then it's quadratic. Perfect. All right, guess what? Example 3, go. You and your partner, A, B, and C, we're going to figure out if they are linear, quadratic, or neither. Anybody reach any conclusions? What did you think about the first one? Neither? Got some random points out there, I don't know, but it's not linear or quadratic. Would everyone agree with that? How about the second one? Linear. Average rates of change are the same. And then how about the third one? Quadratic. Because our average rates of change are all increasing by the same amount. Okay? I have one more point to make and then I will be quiet. I can't really make any kind of, what we just did is fine. I'm getting ready to give you another piece of information, but the next thing I say can only hold true if, and only use this idea if the input intervals are equal length. So these and these are not equal length, so I can't discuss what I'm about to discuss with these problems. This one, I do have equal length input values, so I want to show you something. This set of numbers right here is called the first differences because it's 1 minus 0, 4 minus 1, 9 minus 4. Those are the first differences. The second differences would be 3 minus 1, 5 minus 3. If you have equal length input values and your first differences match, you're linear. If you have equal length input values and your second differences match, you are quadratic. You want me to blow your mind? If you have equal length input values and your third differences match, you're cubic. And so on, and so on, and so on. But please do not use first, second, and third differences unless you have equal length input values. Okay? Well, all right, good job. We'll pick up from there next time.